Okay. But this is, it's really slow. So we have one more time. We have the subset corresponding to the implication. I was explaining if for some reason, the first statement is false, the first statement is false, so then the whole statement will be true always, because we know only true false is going to make false. Only true false is going to be make to be false. And then we have actually, we need the same thing for proving today. So we have one statement that we need to prove exactly by this fact. False makes always the statement to be true. Can I have the negation of this statement? So A subset of B is for all x's in universe, x is in the A, then x is in the B. So what's the negation? What's the negation of this statement?
It's x in the universal set, and then the negation of the implication.
There exists because of universal. The negation of universal is existential in the universe. And then what's the negation of implication? So let's just remind you, when you have P then Q, the disjunction corresponding by that was P naught or Q, right? P naught or Q. So then make the negation to see what it is. So negation of implication is going to be P and Q naught. P and Q naught. So how do I write this? How do you write this one? This is P and this is Q. So negation of implication is P, which means X is in the A, and Q naught, which means X is not in the B. That makes sense. Logically, it makes sense, right? So you're having something which is in the A, but is not in the B. You're having some element which is in the A, but not in the B. So that is exactly not to be subset. That's exactly not to be subset. Make sense? Does it make sense? So equality. When I'm looking to the equality, again, I'm looking to the logic, and the corresponding to the equality, you have biconditional statement. So you have biconditional statement. I'm going to write down what you had as equivalency for biconditional to remind you. So it was P then Q, and Q implies P, right? So that was the biconditional. At the beginning, when we defined what we call biconditional, we just said this is equivalence to both sides, P then Q and Q then P. So this is, I'm going to write down over here what I just said. A equals B. And I'm writing for all of x's in the universe, x is in the A implies x in the B, and x in the B implies x in the A. Do you agree with this? This is P then Q. This is P then Q. This is Q then P. This is Q then P. So your A equals B, same as A is subset of B and B is subset of A. Actually, we knew this one from algebra classes, right? If two sets are equal, means A is subset of B and B is subset of A, right? That makes sense? Any question here? So as of now, for all of these calculus classes, algebra classes you have had, you always accept anything. So when I say this is theorem, like differentiable function are continuous, so you accept it. You don't need to know the proof, right? So for now, whichever statement that we have in 270A, actually only 270A, because 270B doesn't have any proof. Only in 270A, you have to show, you have to prove, you have to bring a reason why this is true. So it's exactly proving course, okay? So like this theorem, it says if you're having A is subset of B, so this means your statement, the P statement is A is subset of B and B is subset of C, then the conclusion is A is subset of C, okay? So these are what you already know. This is what you want to show. Conclusion. Okay, so it's always any of this kind of a statement that we have as a theorem, they are implication statement. They are implication statement means you know something, so which is called hypothesis. It's called assumption. And then you trying to show something or you want to prove something, which is called conclusion. Okay, so for me, the P or the hypothesis is A subset of B, that's what we know. B subset of C, these two we already know, but what we want to show is A subset of C. So you can think about, you know this P is true statement, and you want to show the Q is true statement. So P is already a true statement, is accepted, or is assumption, is hypothesis, is none, but the Q is what you're supposed to show is true statement, okay? Let's write the proof. You assume you have A and B and C, B the sets. So then assumption or what's given was A is already subset of B and B is already subset of C. So I'm going to write in different color. We need to show that A is subset of C. So which is the same as for whichever element of the universe, if X is in the A, you need to show X is in the C. That's what you need to show. I'm okay by now? Are you okay? Do you agree by now? There are something that's given, there are something that you need to show. Whichever is given is called P statement or hypothesis, and whichever you need to show is just the Q statement or conclusion, okay? So you consider there is one X in the universe, and which is the arbitrary element. And then since you assume X is in the A by A is subset of B, then X is also in the B. And again, since you're having B is subset of C, so whichever element is in the B is also in the C. Maybe I add one if here. So I have started with one arbitrary element, which was in the A, and I end up to the C. That's exactly what you want to show. You have something in the A and you want to show in the C. In the C, sorry, I didn't write the notation completely, in the C. So then for any arbitrary element that you got from the U, if it was in the A, you could show is in the C. Do you guys know what we call this kind of property? Do you know the name of this property? A is in the B, B is in the C, A is in the C. What do we call this property? Transitive? Transitive property. It's called transitive property. This is called transitive property. We have it in this course. If you don't know it, we do have it and we do cover it here in this course, okay? Any question here? Do you have any question? Move on. Agree with my proof? Can I move on? This is a good one. This is a good one. I'm going to save it for my next class for recap. So I'm going to prove first this one. First of all, about the statement, it says if you have any set, empty and itself is going to be always subset. Empty is always a subset. The set itself is always a subset. Empty and the set is always a subset. Empty and the set is always a subset, okay? So think about just, that's not the solution. I'm just writing the rough idea, right? So if you just want to show empty, if you want to show empty is a subset, what we just learned about definition means for whatever X is in the universe, if X is in the empty, then you have to show X is in the A. What do you think? Why this statement is true? Why this statement, no matter what, is going to be always true? No idea? Why this statement is always true? Why that grade, the top statement is going to be always a true statement? Because there is no element, yeah. So because we do not have any X in element, we don't have any X in empty set, okay? So that means this statement is going to be always a false statement because empty has no element. Thank you. So empty has no element. So the first statement is going to be a false statement. That's the implication. Implication, if your first statement is false, is going to be always false, right? Only true false is false. Okay, I'm going to write down exactly what I explained. Okay, that's my proof actually. So the proof for this one, you just say, let your having A to be arbitrary set. And then we're supposed to show what did I say? Empty to be subset of A. So to show this, so we need to prove, what did I, exactly the same thing that I wrote on the top. For every X in the U, in the universe, if X is in the empty set, then X has to be in A. So you let X to be in the U, arbitrary, and then this implication, as we said, is always it's always true. X in empty is false. So that shows empty is subset of A. So no matter what, empty is one, what we call trivial subset. It's a trivially subset, okay? And exactly the same way you can write for the other one. Exactly the same way you can write for the A. We need to show A is always subset of A. So, which logically means for all X's in the universe, if X is in the A, then X is in the A, which is always true. Let's X to be arbitrary. And assume X is in the A. So then clearly X in the A. Thus A is subset of A. So these are really the first time that we are trying to write any type of proofs, right? So those wording are really necessary, like X is taken arbitrary. That's exactly the same as for all X's. So that's exactly the same as for all X's, X is in the universe, okay? So those wording are the first try that we have for writing a proof for a theorem. Okay. Go ahead. Then clearly, X is in the A, okay? Can we have the true-false problem? Is the first one true? Is empty a subset of empty? Is it true? Is the first one true? Empty is subset of everything. So that's true. The next two are interesting. So what's the difference between the next two? The first one has one as an element. So your one is the element. The next one has the set of the one as element, okay? So which one is true? Is the set of one subset of that. This is true. The next one. The next one is false. You see, if it says this is elements of 1 and 2. Is that true? This is exactly one element of your, set. If you want to have the subset, you can say this is a subset for this one. So we need to know 1 is not the same as 1. 1 by itself is one element, then 1 inside the set is a set included 1. They are not the same. You need to know 1 is not the same as 1 and 2. So you can't write 1 and 2 and then you have a set of 1 and 2. It's like a wrap, it's like a package, it's just inside of something, okay? So if I can say this is a true, but the first one is false. Make sense? Do you agree with this one? This set has 2 elements of 1 and 1 and 2. Okay, move on. Next one is the power set. The set of all possible subsets. The set of all possible subsets is called power set. The notation is P. The set of all possible subsets is called power set. The notation is P. So this is one example. You're having 2 elements. This is 2 elements. If you want to write the set of all subsets for A, empty is 1. 1, 2 is another one. 1 and 2 is another one, right? So if I want to separate them, this is subset of A. This is also subset of A. So you're having 4 elements. So your subset, your power set of A is empty, 1, 2, 1 and 2. So this is the power set, the set of all subsets. Okay. Can you tell me what's the power set? What's the power set for B? What's the power set for B? Empty is one of them for sure, right? So empty is one of the subset. What else? only one, which is the same as B. Do I have anything else? Your power set of the B has only empty and 1. This one has 2 elements, this one has 4 elements, 4 subsets. What's the rule for number of subsets? What's the rule for number of subsets? Do you guys remember? You knew this one, right? Power set has 2 to the power of n elements. So one more time, number of subsets is 2 to the power of number of elements. So here is 2 to the power of 2, so you got 4 subsets. Here is 2 to the power of 1, you got 2 subsets. This is what we assume you knew, right? So you knew before coming to this course. Anyone remember or anyone have any idea why 2 to the power of n? Where is 2 to the power of n coming from? Anyone remember where this 2 to the power of n is coming from? No, you don't remember? Almost, right? So it's almost, yeah. You can think about when you have one element, so when you have n elements, when you have n elements, you have 2 choices. 2 choices of being in subset or not. Do you remember your counting? So being in this element is one choice, not to be in that subset is just another one. So then each time when you have one element, you have 2 choices of being subset or not. So it's 2, and then 2 choices of being this for the next element or not. For next element, the same, 2 choices of being the subset or not. So that gives you 2 to the power of n. So for each element that you choose, you have 2 choices of being in subset or not. So that gives you 2 to the power of n choices. That's a fundamental counting principle. I need to write down, right? We always construct any subset of A by exactly choosing whether or not each of these elements is included. So there are exactly what we said, 2 times 2 times 2 to the power of n different choices. Agree? Do you agree with this one? Okay, so then can you practice writing the possible subsets or what we call power set or possible subsets, all possible subsets of alpha, beta, gamma. You have 3 elements, you expect to get 8 of them. You have 3 elements, you expect to get 8 of them. Can you try to write down all of them? Okay, give it. What do you have? Your first power set, that's a notation, right? So we write it like this. Alpha, beta, gamma is your element. Then you put it inside the parentheses. So then you list them. You start with no element. Then 1 element. Then
Whatever that.
What was that? What's that last one?
beta, gamma.
Okay.
Then
Alpha, beta. Alpha, gamma. Beta, gamma. Alpha.
so that would be 8 of them, huh? Let's write another true false. Let's write another true false. Is it true to say alpha is subset of power set of alpha, beta, gamma? Is this true? You can compare with this one. Just practicing the notation, okay? Which one is true, which one is false? Or this one also. Elements. Which one is true? You see what's the differences, right? You see what's the differences, right? Which one is true? Is this a subset? Is this a subset of the power set? Or is the element of your power set? Is it a subset of your power set or is an element of your power set? It's element. It is element. This is true. This is false. It's not subset. It is not subset. Okay, so if it was subset because it's right there, right? If it wants to be subset, you have to add another one. You have to add another one. Is alpha by itself without that set notation element of the power set? No, right? That's false also. Question here?
So if it doesn't have it, is it included as a set?
If it doesn't, can you repeat it?
So if it doesn't have graph holding it, it's not a null, what's it called?
So if what did I say? I said, if this want to be true, you should have this way.
Exactly.
This is true then. Then this is true. Because that's one element which is sitting inside a set, so it's going to be a subset.
Oh.
But this is one element which is element. It's not set.
What if it was, and if it was standing alone, that would still be false, right?
You mean here or what do you mean?
Yeah, alpha is a subset of the statement.
That's false. That's false because for this notation, you need this notation. Because element by itself can't be subset. You need that set notation. Sorry, I have to fix all of this, huh? Not that much. Okay, move on. Can I move on? Any question here? You guys have any question? So the concept of how many minutes do we have? About 5 minutes, huh? Anything, any question, any confusion? So we don't have any problem with the union, intersection, subtraction, right? So you guys remember, you've seen this kind of operation for sets in algebra classes. We need to review, obviously, it's years ago, but we know what they are, okay? So again, I'm not worried about the algebra part, I'm worried about the logic, right? So you can think about the notations, like if you're having intersection, then it's this similar exactly, right? It's conjunction, right? If you have union, it's this notation, is disjunction. If you have subtraction, actually is and statement. And because of those true false statement that we know about, and has to be both true, and has to be both true to be true. But here, if one of them is true, is okay. If even one of them is true, the other one is false, the other one is false, this is true, still is okay. So then you can think about what you have learned as union. If I just say this is cap, this is cop, and that's a minus. Okay. So again, if you think about the logic, your like union right over here will be only false if both of them not, right? So if you're having X not in the A, not to the B, so that makes it false. Otherwise, it's going to be true. Or like intersection is going to be true if both of them are true. So if one of them fail, so if X is not in A or X is not in the B, then it doesn't work anywhere. So it's not going to be in your intersection. Does it make sense? The logic for the union before doing the numbers, before doing the examples? Are you tired? You don't want to listen anymore? That's obvious from your faces. So I give you a little bit time to just again chat with your friends in your group. If you're, I'm going to stop here.